Hello friends, welcome to my channel Emulation Nerd. So as you can see on my screen, today I'm not going to discuss about data engineering module. So I thought we can discuss of every topic concurrently so that we can develop or at least I can help you develop basic concept of each and every topic of data structures and algorithms as well as some CS fundamentals. So it helps a lot in getting you job in big tech giants. So as you can see on my screen, I will be discussing about the data structures and algorithms today, and in this I chose for today what is called a greedy algorithm. So greedy algorithm is the basic of all the algorithms which you need to know in order to build an algorithm. So this will be going to be the very first concept of data structures and algorithms. So let's dive in. So in the greedy algorithm, I will be discussing about some general strategies what we need to have to develop a greedy algorithm, and step by step what we need to do in order to develop the approach for the greedy algorithm, as well as at the end of it I will also explain you with an example of how a greedy algorithm works. So let's go. So talking about the approach or some what we call a general strategy of grading algorithm, I will write it down here. So what happens in greedy algorithms is that you are given a problem, and for that problem you need to find a safer move by greedy choice. So what is a safer move then? A safer move what we call is a move using which we can just generate a solution to the problem we are provided. So the safer move in the greedy choice can contain of any subsets of all the supersets. So let me just write it down here. Given a problem by a greedy choice, for sake of complexity I will just write GC for the greedy choice. We need to find a safe move. And for this safe move, in order to build that, we need to break the problems into sub problems. So let me just write it down first. I will explain you a bit afterwards. And the sub problem cumulatively results into the original problem. So now talking about the sub problem, what a sub problem is. So consider a situation you are given a problem to solve, and the problem can consist of multiple subparts which you need to solve independently, and by organizing the results of those subparts you can just generate the result of the original problem. So this subproblem will be that subpart which I was talking about. So this is the general strategy for any greedy algorithm. Now let's talk about the steps what we need to take in order to develop a greedy algorithm. Mm, yeah. So in order to develop a greedy algorithm, first and foremost, we need to make a greedy choice. I will explain each and every step why the greedy choice and what happens with each step. So first and foremost, greedy choice, and after that If we choose a greedy choice, we need to prove whether it is a safer move. And after safer move, we need to reduce the problem given to us into for to the sub problems. And lastly, we need to solve the sub problems. And by solving this sub problem, we get all the aggregated values of all the sub problems, which ultimately results into the solution of the original problem. So let me just explain each of it a bit. So what a greedy choice is. Greedy choice means that suppose you are given a superset and you need to find a subsequent or a particular set with some particular conditions. So in order to find that particular subset, we can have we can have a set of all the subsets that we can make from that superset. So that can be a greedy choice, and we need to prove that a greedy choice is a safer move. The move which we are going to make is a safer move. So how can we prove that? So in order to prove that, in the problem we might be given some constraint, the input constraints as well as the problem direction in which we need to solve the problem. So in the greedy choice, we need to check for the greedy choice whether we are meeting those constraints or not. And after proving this, we need to reduce the problem into the sub problems which I talked about during the sub problems. We need to break the problems into minor pieces and solve it independently. And after that, we need to solve the problems, and after solving the problems, just aggregate all the data from all the sub problems, and we get the solution of our general problem. And yeah, this is all about the greedy algorithm, how it works. So I think I made all the things clear to you. If anything I left out, or if something isn't clear to you, please comment down in the comment section and I will make a separate video regarding that. So now let's look it through an example of how it works. Let me have a question in order to illustrate it. So yeah, suppose in a party many children came to the celebration, and we need to organize them into minimum possible number of groups such that the age of any two children in a group shouldn't differ by more than 1 years. This can be a good greedy problem. So let me just write the problem for you. Or instead of party, we can generalize it as a celebration. So yeah, this is the problem I am talking about. So I think the problem is clear to you. We need to make the minimum possible number of groups of all the children in a celebration such that every children in a particular group such for every children in a particular group, the difference of the age of each children shouldn't differ by more than 1 year. So let me explain you with an example here. Suppose there are four children that came to a party. Child 1 has age of 1 year, second has age of 3 years, third has age of 2 years, and fourth has age of 1 year, let's say. So this will be the child 1, child 2, child 3, and child 4. And in this we need to make minimum number of groups such that for every children in a particular group, for every children in that group, the difference in the age should not exceed more than 1 year. So there is one possible situation that we can organize one, and let me see, just write the child name C1 and C4 in one group, and C2 and C3 in other groups. So in this situation, C1 has age of 1 year and C4 has age of 1 year respectively, and C2 has age of 3 years and C3 has age of 2 years. So if you look at these numbers, here the difference is 0 and the difference is 1. So we ultimately met the constraint that is given into the solution. So we can consider it as a safer move, or it is one of the solutions. So there might be, you can think of other solutions as well. Suppose you might be thinking of organizing C1 and C3 and C2 and C4, but you look onto the numbers here. C1 has age of 1 year and C3 has age of 2 years. So in this situation the difference at max is 1 year, and it successfully met the situation or condition given in the problem. But if you look at the second group, C2 has age of 3 years and C4 has age of 1 year. In this situation the difference is 2. So this, in this situation it doesn't meet the constant given in the problem. So seeing this this situation shouldn't be our solution or any of the move we should take. So talking about the greedy approach here, we need to, what we need to do is, as for the greedy approach solution, we need to divide the given number of children into the smaller sets, or you can say we need to form all the possible subsets from the given superset. So let me just write the naive approach. The naive approach always called the greedy approach for better understanding. uh, yeah, in the naive approach, suppose we have a function that returns min group, and the function is provided with the set of children that are in the celebration. That means the C, we denoted by C. Now in this function we can have a variable m that stores the length of the set provided. So bear me with this, with all those errors which I am doing while sketching it out. So we have the length of the set C provided to us, and now as per the greedy approach we thought of, we need to create all the subsets of the superset provided, and where the superset is the set C, superset is set C. Cool. And so we need to iterate through all those subsets. So for each partition, into groups. And for each partition into groups, what we assume is that C is equals to, just for the sanity check, group 1 union group 2 union group 3 union, and it goes on till union of group K. So these are all the groups or the subsets that are made from the superset C, and we need to sanity check where the union of all the groups will result into the C. Yeah, we should have a separate variable here called as good. This can be a boolean variable and can be initialized to true. And after that, we need to iterate through all the indices from 1 to k, so that we need to just compare of all the age groups in a particular, all the age of the children in a particular group. So for I from 1 1 to k, and check the following condition: if maximum of age in group I minus minimum of age in group I is greater than 1, then this group can't be a particular solution. So we can just set the boolean variable as false. And now, after the iteration through each of the groups formed, we need to check if all the groups formed are suitable for a solution. That means if good is true, you can simply write it as if good, or you can just check it as equals true. We need to have a separate variable named m. M should be minimum of uh, the length of the set provided and the k value. I mean the number of groups formed. Why it should take the minimum? Because the maximum number of subsets that can be formed is m, because in ideal situation, if every students are segregated and each subset contains of one children, then in that situation the condition is met. So we need to check the minimum of m and k. So the k can exceed the minimum, the length of set c, because uh, it can create a situation where the subsets can contain an empty set. So in that situation k will exceed the length of the set provided. So it will have the minimum number of the sets that can be formed, and after each partition into groups we need to return and we just computed here. So this is a general approach of the problem given. So I think I made everything clear to you regarding the greedy algorithm. So talking more about greedy algorithm, it doesn't take any much time. So you, in order to practice, you can just log into the code forces and sort the problems according to a greedy problem approach, and then start solving it. So I just noticed that I haven't introduced myself to you, so I will be making a few videos in the coming time, and after that I will uh, s- clearly introduce myself, because after that you will be more interested in learning who I am. So yeah, this is all about the greedy approach. So if anything I left out, or if anything you didn't understood, please comment down in the comment section, and I will surely reach out to you or make a separate video regarding that, aggregating those solutions. So this is all about the greedy algorithms in the data structures and algorithms module. Hope you like it. So please tune in, like, comment, subscribe, and share as much as you can. Thank you, and see you in the next video then. Bye bye.